So hello, this is the AI solution for the POC project LangGraph. So what this project mainly does is, like, I have created this project to demonstrate a multi-agent AI system using LangChain, LangGraph, AstraDB, and a simple Gradio UI. This basically intelligently routes the user question either to the RAG system or to the Wikipedia agent, depending upon the topic. Like whatever the information is present in RAG, it will direct it to the user question to the RAG, and if the user question is not present, it will direct it to the Wikipedia. So after that, we should go through the backend code. So yeah, this is basically we install dependencies like LangChain, LangGraph, and Casio. Casio is used to connect to the AstraDB. Then we took that AstraDB application token and AstraDB ID, and then using Casio we connected it to the AstraDB vector store. After that we installed LangChain community. Then we installed LangChain Grok. This is basically a API web house, or we could say an LLM web store where you can use the API to use all the LLMs for free. Then we use tick token. It is usually used to count the number of characters in a document. Then LangGraph and LangChain Hugging Face, basically to use the sentence transformer that is used to create the embeddings. So after that we took the three URLs which are used to create content for our RAG. Then we use the web-based loader to load all these documents, and then one by one we stored all the documents in this docs list. And then after that we used text splitter to convert this all documents into chunks, and then we stored all these documents in doc split. And then these are all the documents which are stored in the doc split. And then after that we call this model all mini L6v2 using Hugging Face embeddings to create the embeddings. Then this is basically used to create embeddings and store it in the AstraDB vector database, and we kept the table name QA mini demo. So here is this QA mini demo which is stored in this. After that, all the this is to store all that data headlines in that Astra vector store. So these are stored in that. Then after that, we created a wrapper function to use this vector store. So we stored it in the retriever, and then we used it as a retriever, which then asked the question like what is an agent. So it returned all the answers which were present in that vector store. After that, we created LangGraph application. Basic imports which we done were chat prompt template, base model, and field. So class root query, route a user query to the most relevant data source, and then we just mentioned two data sources, vector stores and wiki search. And then the field which we mentioned were given a user question, choose the route if it is a Wikipedia or a vector store. So this is basically to use that Grok API, so or basically the model which we want to use. And here we have initialized the model which we are using Gamma 29B. And then this is the prompt. You are an expert routing user question to a vector store. The vector contains documents related to agents, prompt engineering, and all. So the user will put the question and the system will return the answer. So the question router can go into the root prompt or in the structured LLM router. It depends upon the question. So like we asked who is Shah Rukh Khan. So it went into wiki search, and then we asked what are the types of agent memory. So it goes into vector store. Because this information was not present, like who Shah Rukh Khan was not present in vector store, so it went to wiki search. Then we installed the LangChain community again, and then the Wikipedia to create Wikipedia function. And these are all the tools which are used for Wikipedia. So whatever the documents which we will get, it will chunk into, like it will retain maximum characters about 200, and then this is the API wrapper to how to use it. Then basically we created the graph and the state of the graph which it represents are the question, LLM will generate it, and then the list of the documents. So state of the graph, the current graph state, and the new states added document that contains the retrieved question. So the question will come, either the question will go to the documents or the question will go to the retriever, or it should go to the wiki search. It depends upon that. So this is basically the wiki function, like how it will come. The question will come and it will go into the wiki results. So basically when the question will come, either it will go into the retrieval, so this is the retrieval function, or it will go into the wiki search. Then these are the edges. The question state equals to question source if we invoke the question. If the data source is in wiki search, then the root question is in the wiki search, or else return the footer. These are basically, now we are creating like the flow of the graph, how it should go. So we define the nodes like wiki search and retrieve, and then we build the graph like start, and then we either the question should go into the wiki search or in the vector store, and then it should go into the retrieve or it should end, and if it goes to the wiki search then also it should end, and then we should compile. Then here is the image of that. We will start whether the question is present and it will go into the vector store, it will retrieve and then it will end, or either the question will go into the wiki search and then it will end. Then we basically test it like what is an agent, so it returned the answer. And then we test it like what is who is Son Goku, then it returned from the Wikipedia. Then we install Gradio, and this is basically the Gradio interface. So like if I'll search what is Son Goku, or basically who is Son Goku, who is Son Goku, so it will return the wiki search. Son Goku is a fictional character and the main character of the Dragon Ball manga created by Akira Toriyama. And if I write what are the types of AI agents, so it will return from the retriever. Learning session. So yeah, this is basically the solution for this. Thank you so much.